In this session, we'll discuss about the slope deflection method for frames. So building frames can be analyzed by various methods like a force method, displacement method, approximate method, and Canis method. Unit load method comes under force method, and slope deflection method, moment distribution method, and direct stiffness method, etc. comes under displacement method, and portal method, cantilever method, point of inflection method comes under the approximate method. So coming to the definition of sway, it is nothing but the relative displacement in horizontal plane. So you can see in the figure a frame, and there is a horizontal force at B. So due to that horizontal force, the frame tries to bend to the right side. So the horizontal displacement, the relative displacement in horizontal plane is delta, that is the sway here. So what is the difference between sway and non-sway frame? So for non-sway frames, the first condition is if the columns of the frame are symmetrical. If the columns of the frame are symmetrical, it is known as non-sway frame. The second condition is, so columns symmetrical means the columns AB and CD should be of same length, L and L. Means A and D should be at same level. If they are not at same level, or the height of the columns A, B and CD are different, then it is known as sway frame. The second condition is loading on the frame should be symmetrical. So if the loading is unsymmetrical, it is a sway frame. If it is a symmetrical, it is a non-sway frame. The third condition is supports of the column of the frame should be symmetrical. So the supports of the column of the frame should be symmetrical. That means at support A and D, if it is fixed at A, at D also it should be fixed. If it is hinged at A, at D also the same hinge support should be there. That is the meaning. The sway frame is a completely vice versa of these conditions. If any one of the conditions stated above are violated, then it is a sway frame. For frames, degree of static independency ds is equal to degree of external static independency plus degree of internal static independency minus r dash if there is any internal hinge. So ds is r minus 3 plus dsi is 3 into c. C is number of closed loops minus r dash. So kinematic independency dk for a fixed support, dk equal to 0 at fixed support. Number of degrees of freedom is 0. Now let us see a problem here. So analysis of a frame, portal frame, a non-sway portal frame using the slope deflection method. So a continuous beam ABC is supported on an elastic column 3D and is loaded as shown in the figure. Treating joint B as rigid, analyze the frame and draw the bending moment diagram using slope deflection method. You can see a portal frame there, T frame, and this is a non-sway frame because it is at A there is a fixed support and at C there is a hinged support, at D there is a fixed support. So it cannot move. There is no chance for sway. So the very first step is to find the fixed end moments. MFAB equal to minus WAB square by L square, IMFBA WA square B by L square, MFB because it is a eccentric load, and for BC as it is UDL, the fixed end moment formula is minus W square by 12 and W plus W square by 12. And as there is no load on BD, MFBD equal to 0, MFDB equal to 0, fixed end moments is 0. So the next step is to apply the slope deflection equation. MAB equal to MFBA plus to EI by L 2 theta A plus theta B minus 3 delta by L. So here as there is no sway, this frame is non-sway frame, delta will be equal to 0. So for non-sway problems, so delta will be equal to 0. But theta A here is 0, theta B is unknown, theta C is also unknown. So we will get MAB the equation 1, for MBA we'll get equation 2, for MBC equation 3, MCB equation 4, MBD equation 5 and MDB equation 6. So in MAB equation we need to substitute theta A is 0 and delta is 0. In MBA equation we need to substitute theta A equal to 0, delta 0. In MBC we need to substitute delta equal to 0. In MBC we need to substitute delta equal to 0. In MBD and DB we need to substitute theta D is equal to 0, delta equal to 0. Then we'll get 1 to 6 equations. In the next step, we need to apply the joint equilibrium equations. So here at joint B, we have a joint equilibrium equation MBA plus MBD plus MBC equal to 0. And at joint C, as the moment is 0, so MCB is equal to 0. So substituting those equations here, we will get 7th equation and 8th equation. So solving 7th equation and 8th equation, we will get EI theta B and EI theta C. So substituting in 1 to 6 equations, we can find the fixed end moments MAB, MBA, MPC, MCD, MBD, MDB, everything we can find by substituting these EI theta B and EI theta C values in 1 to 6 equations. So in this way we can find final end moments. Finally, we need to draw the bending moment diagram. So first of all, we will draw the bending moment diagram for simply supported case. So for simply supported means for eccentric point load, WAB by L is maximum point load, and similarly, at BC, on the BC you have a UDL, so WL square by 8 is a maximum bending moment. So then after that, you can add the final end moments in this bending moment diagram by using the sign conventions. So you can see the sign conventions here for beam and column, plus minus minus plus. So in this way we can draw the final end moment diagram, net bending moment diagram. So net bending moment diagram we can draw in this way. So this is how we will solve the problems, non-sway problems using slope deflection method. Thank you so much.